Bucharest. I welcome you all to my talk about web application firewall bypassing, an approach for pentesters. My name is Khalil Bijou. I'm a security consultant for a company called EUROSEC. We are a consulting company in Germany and do security since 1998. So the first question is, bypassing a WAF, why do we even want to do that? First of all, more and more companies are deploying WAFs in their infrastructure. So the number of WAFs is increasing. And WAFs, from the perspective of a pen tester, make a penetration test, a security assessment more difficult. So attempting to bypass a WAF is a very important aspect of a penetration test and should be in the skill set of every penetration tester. So the goal of this talk is to provide a practical approach for penetration testers on how to bypass a WAF, because ultimately our aim or our goal is to provide accurate results to the customer and tell him you have vulnerabilities in your application and they are exploitable or whether they are not. But before we dive into the bypassing, we first of all have to know a little bit more about web application firewalls. So first of all, in the old days, companies were using firewalls and intrusion detection and prevention systems. The problem with these are that they work on the transport layer. So they don't understand application logic very well. One of the problems of firewalls and intrusion prevention systems were that they tend to false positive. So they were blocking requests that aren't malicious at all, or that they didn't even detect a payload. So what we needed was a firewall that understands application logic more or better. So web application firewalls were introduced and they replaced these old-fashioned firewalls and intrusion detection and prevention systems for web applications. So what does a web application firewall do? It provides an additional security layer to infrastructures and checks for malicious traffic, and if it detects malicious traffic, it blocks it. Coming to the functionality of a web application firewall, the first thing is that a request is incoming. So the web application firewall runs the preprocessor. The preprocessor decides whether a request will be further processed by the WAF or whether it will not. So for instance, if the web application firewall sees, this request comes from an internal IP address, it may just skip it and send it to the backend. In the next step, after the preprocessor, the WAF performs normalization functions. So the input may vary from application to application. Sometimes we have Unicode, sometimes we have hex encoded characters. So what we need is a normalization of this input. And after that, the input is validated by the WAF. So the WAF has some rules in it and checks the user input against these rules. And if everything is fine until now, the request will be forwarded to the backend. Yeah, so to understand the normalization functions a little better and their purpose, first of all, normalization functions simplify the writing of rules. So if you have an administrator who wants to define some rules for the WAF, he does not have to know about the different encodings or the different variations of input. So for instance, we have here 4 functions which are used by Mod Security, which is a very famous web application firewall used in many environments. For instance, we have the compress whitespace function, which converts whitespace characters like a horizontal tab or a vertical tab to normal spaces. Then we have the hex decode function, which also is clear. It decodes a hex encoded string. We have the lowercase function, which converts characters, uppercase characters to lowercase characters. And finally, the last example is the URL decode function, which decodes a URL encoded string. Then the input validation of WAFs comes after the normalization functions. And here we have different security models. And these security models define how to enforce the rules. They mostly consist of regular expressions. And generally, we have three security models: the positive security model, the negative security model, and the hybrid security model. To have a deeper look into the first two security models, here's a short comparison between the positive and the negative security model. So the positive security model is also called whitelisting. The general rule is deny all but known good. So the general rule is to deny every request except if we find something in it that we have defined as good. The advantage of a whitelist is that it prevents most zero-day exploits. So for instance, if we have a parameter ID, we can assume that the input for this parameter will be only integer numbers. So if there is a zero-day exploit, it will be very unlikely that it will work. So we can say that the whitelist model is more secure than a blacklist model. But the disadvantage of the whitelist, and this is probably why most companies do not use it, is that for setting a whitelist up, you have to have a comprehensive understanding of the web application. So the administrator needs to know what is the application about, what does it do, what parameters does it have, and what is a valid input and what is not. So creating the rules for this whitelist is a time-consuming process. On the other hand, we have the blacklist model. Here's the general rule: allow all but known bad. So every request is fine and is allowed by the WAF, except for those requests where we find something bad. The blacklist mostly comes shipped with the WAF, so we don't have to create a blacklist ourselves. Another advantage is the fast adoption. So we may buy a WAF or install a WAF and we can use it right away. The administrator who is deploying the WAF does not need to know anything about the application. In general, he doesn't need to know a lot. He can just deploy it and it will work. How good it will work is the other question, but it will work. And finally, it will a blacklist, and this is probably why most companies use them, are able to protect several applications. As we define what is bad input, we define what is the bad input, and the bad input is not just bad input for one application, but for all our applications. The problem with the blacklist is that it tends to false positives. So if any one of you may have used once mod security with the standard blacklist rule set, you may have encountered several error pages where you were just using the application normally. So for instance, if you want to use mod security with a CMS like WordPress, you may forget it if you don't disallow, or if you don't disable some of the rules. And another thing, which maybe not a big disadvantage, but it is a time-consuming process for the WAF to check every request against a very, very long list of bad inputs. Okay, that's about the functionality of WAFs. Coming to bypassing methods and techniques. So these techniques and methods can be categorized into three different parts. The first part is the preprocessor exploitation. Here we try to make the WAF skip input validation. So maybe we can try to, I'll give an example later. So we try to let the WAF think, this request is okay. I don't even have to see in it, look through it and try to find any bad payload. The second category is the impedance mismatch category, where we try to find a payload that is interpreted by the WAF differently than the backend. And finally, we have the rule set bypassing, and this is probably the category where the methods are most likely to work. We try to find payloads that are not detected by the WAF. So coming to the first category, preprocessor exploitation. One example for this category is skipping parameter verification. Here we try to find an alternative for the parameter name, which is interpreted by the WAF differently. So for instance, we have PHP, which removes white spaces from parameter names or transforms them into underscores. So we have this URL, website.com/products.php %20, which is a URL encoded white space, product ID. So this request comes into the WAF, and the WAF sees %20 product ID and tries to match it against all parameters it knows. And it doesn't find one. And in the back end, when it comes to the PHP web server, or the web server which uses PHP, the white space is just removed, and we have the parameter name product ID, and it will be processed correctly by the backend. The same applies for ASP, which removes a % character, which is not followed by 2 hexadecimal digits. So again, we have the example website.com/products.aspx %product ID. Again, what does the WAF see? It sees the %product ID. I don't know this parameter, so it will be fine. And when it comes to the backend, ASP then just removes the % and sees product ID. And yeah, if a WAF is configured in such a way that it does not reject unknown parameters, it may be bypassed by this way. The second example is a malformed HTTP method. So if we have a web server that is misconfigured and accepts HTTP parameters that are not defined in the specification, like in the example, hello 123, and we got a response of 200 OK, then we may try this method and hope that the WAF only inspects get and post parameters and skips every other HTTP method. And the third, a little bit brutal method is to just try to overload the WAF. So a WAF may be configured in such a way that it skips input validation if performance load is heavy. And this often applies to embedded WAFs, because we as a company do not want to reduce the usability of our application, and most companies then favor usability over security. So what we can do is to send a great deal of malicious requests and try to overload the WAF with this technique, and hope that some of our requests gets through the WAF and will be sent to the backend. Okay. The second category is impedance mismatch. Again, what we here try is to find a payload that is interpreted by the WAF differently than by the backend. A very famous technique is called HTTP parameter pollution. So what we do is we send a request with, or a number of parameters with the same name. So for instance, we have website.com/product/product ID =1 and product ID =2. So we have the same parameter name with 2 different values. How do different technologies interpret this request? ASP.NET concatenates both values with a comma. So what gets to the backend is product ID equals 1, 2. JSP, for instance, just uses the first occurrence. So what it processes is product ID equals 1, and PHP uses the last occurrence, and it gets product ID equals 2. So if we assume that we have the following payload, product ID equals select 1, 2, 3 from table, then probably every WAF will block our request. But what we can do if we have, for instance, an ASP.NET application, we can try to divide our payload and send product ID equals select 1 and product ID equals 2, 3 from table. So what the WAF sees is 2 different parameters, or 2 individual parameters. The first one, select 1, is not malicious, and product ID equals 2, 3 from table, which is also not malicious. But would we have sent the whole request in just the first parameter, then the WAF may detect it. And this was actually a bypass for mod security in 2009. Yeah, and as I explained, ASP.NET sees these 2 values and concatenates both with a comma, so what we get in the end is what we have above. Another technique is WRL encoding. So what we try here is, or what a WAF normally does is it normalizes the URL encoded characters. If the WAF is configured in such a way that it decodes the URL encoded parameter or the URL encoded value only once, then we may find a bypass. So what we try is to take a character like the S in the example and URL encode it, which gives us %73, sorry. And this again, we URL encode this again and get %25, %37, %33. So we try to craft our payload then with, which you can see on the bottom, 1 union and then our WRL encoded S, elect 1, 2, 3. So what hopefully happens is that the WAF receives the request, decodes it once, and still sees %73, and says, okay, this payload is okay, I don't find it in my blacklist, so I can give it to the backend. Okay, coming to the last category, which is rule set bypassing. So in the rule set bypassing, we have 2 methods. The first one is a brute force method, where we just try different payloads and hope that one of our payloads gets through the WAF. This is a very simple approach and probably not the best one. But the more intelligent approach is to reverse engineer the WAF's rule set. So what we try is to find out how does the rule set look in the WAF. What is blocked by the WAF and what is not blocked by the WAF. And we know, if we know how the rule set looks like, we can attempt to find a payload that is not blocked by the WAF. And this is probably the technique that is the most successful of all mentioned ones. Okay, so now we have a good overview of the methods and techniques. Just that you know, these are just examples and there are many more out in the wild. Coming to the approach for penetration testers. So the question we want to answer here is, if you are a penetration tester and have an application which is secured by a WAF, what are the steps that you have to take and what are the phases for bypassing the WAF. So to give an overview, first of all, these phases are a little bit similar to the normal phases of a normal penetration test. And it is divided into 6 phases, whereas phase 0 may not be always possible. So does any one of you have an idea what the first phase may be? Phase 0. To find the name of the WAF? Okay, that's very good. So you mean reconnaissance phase. Very good. But even before it, it's something that I think no one thinks of, but the first phase is to just disable the WAF. So what is, again, our objective? Our objective is to find security holes in an application. We want to find bugs and security vulnerabilities in an application. So if we disable the WAF, we can find these vulnerabilities more easily. And eventually, the assessment of the security will provide more accurate results. So what we try to accomplish is to tell the customer to disable the WAF for 1 or 2 days. And if the WAF is disabled, we can have a more focused approach to find vulnerabilities, or find where the vulnerabilities in an application are. And if later the WAF is turned on again, we can try, we know where to search. But that's why it's called phase 0. It may be not realizable in every penetration test. For instance, if the customer wants you to test a productive system. And after that, as you said correctly, is the reconnaissance phase. So what we try here is to gather information about the target, about the WAF, about the web server, about the programming language that it was used, about the Perfect, thank you. Okay. Okay. Phase 3, finding an impedance mismatch. Impedance mismatch, to remember you, is to find a payload that is interpreted by the WAF differently than by the backend, and therefore it may not detect it. So what is really important here is, is to have knowledge about the backend system, which we have hopefully acquired in the reconnaissance phase. In the fourth phase, we try to bypass the rule set. Again, we have the brute force method, where we just brute force our different payloads and hope for a payload to be not detected by the WAF. And we have the more intelligent method, where we try to reverse engineer the rule set. So what we actually do is to send symbols like a double quote or a smaller sign or a bigger sign, and see, does the WAF block our request or not. Then we observe whether the string or the character is blocked or not, and in the end we have a nice list of the rule set of the WAF. We know which characters are blocked and which are not. Phase 5 would be to find other vulnerabilities. So there are vulnerabilities that cannot be blocked by a WAF at all. For instance, if we have vulnerabilities in the application logic, for instance, a broken authentication mechanism, or a privilege escalation vulnerability, and so on and so forth. So these vulnerabilities cannot be detected by a WAF, and we have to assess the application for such vulnerabilities. And phase number 6 is after the pen test. So now is the phase where we are done with our penetration test, and we have to inform the customer about the vulnerabilities that we have found. So the best advice that you can give your customer is to fix the root cause of a vulnerability. So if you, for instance, have a SQL injection vulnerability in your application, or a cross-site scripting vulnerability, the customer should not just put a rule into the WAF to block all malicious requests, but should fix the root cause, which is the application itself. For the time being, while the application is getting fixed, the WAF should be a rule should be added to the WAF which virtually patches this vulnerability. And sometimes you may use an application from a third party, or you use a very old application where you do not have the ability to change the source code, where you do not have the ability to fix the vulnerability. So you have to apply rules to the WAF to fix this vulnerability. And what is very important for the customer to understand is that a WAF may mitigate a vulnerability, but it cannot thoroughly fix it. Yeah. Coming to the last aspect of my talk, which is a program I developed during my bachelor thesis called WAF Ninja. So WAF Ninja is a command line interface tool written in Python, and what it does is it automates some of the parts or some of the phases of the approach we have just talked about. It was used already in several penetration tests, and you can now find it on GitHub. It's open source, and yeah, you can find it on the internet. It supports HTTPS connections. It supports the use of get and post parameters, the usage of cookies, and you can also set up an intercepting proxy. WAF Ninja has a function called the fuzz function, or yeah, the fuzz function. So what it does is fuzzing the application. It sends different keywords and payloads to the application and analyzes the response and tries to detect whether the payloads it has sent, whether they were blocked by a WAF or not. And in the end, the results are displayed in a clear and concise way. So we have a nice output at the end where you can just check, is this symbol blocked or not? And you can always extend the fuzzing strings with a function called insert fuzz. So I've prepared a small demo of the tool just to show you how it works. So what we have here is the damn vulnerable web application, which probably the most of you know already. It's an application used to test different vulnerabilities and to get a little bit of experience with these technologies. For instance, we have this field which says, what is your name? And as you can see in the title, the vulnerability is called reflected cross-site scripting. So what we have an input field where we enter our name. So for instance, I enter my name, Khalil. And as you can see, it says, hello, Khalil. What the penetration tester now thinks of is cross-site scripting. So what we now try is Khalil script alert 1 script. And we try to execute our request and see, oh, we got a web application firewall alert. So the application is now secured by a WAF called WebNight, which is an open source web application firewall made by the company Actronics. So our payload is blocked. What are we going to do now? Normally what the penetration tester is going to do, he's going to try different payloads and different variations of his input. So yeah, and this is where the tool WAF Ninja comes into the game. So yeah, what we can first of all do is to start the tool and look at the help file. Whoops. Yeah. Okay, a moment. I'll have to make it a little bit bigger so you can all see. Okay. Okay, I think you can now see what it looks like. I'll make it great. Okay, so this is again the help file. So it says WAF Ninja penetration testers favorite for penetration testing. We have different methods and techniques. We have the fuzz technique, which we just talked about. We have the bypass technique, which is the primitive method of just trying different payloads and hoping that one gets through the web. And then we have other functions where we can insert a fuzzing string or insert a payload string. So we want to use the fuzz function. And this is, sorry, Python WAF ninja.py. Okay. So as you can see, this is how the command looks like. Looks more complicated than it is. So the first thing that we need is a URL. So -u, and I'll copy the URL from here and paste it in. So we use double quotes, and the parameter where we want to send our fuzzing strings has to be changed, and we have to add the keyword fuzz into it. The next thing that we need is, okay, the next thing that we could provide our post parameters, but as we have a get request, we don't need this here. But what we need is the C parameter for using a cookie. So we have to provide the cookie. This is something I have to copy from here. I also have to look on the big screen to see what you see. Okay, here it is. So show me the cookies. It's again here. And I copy the value of it. Says ID. And there is a second cookie called security, which is the setting for setting the security level of the application. So if you set it to high, the vulnerability should be unexploitable. And this security is, this cookie is a cookie of the damn vulnerable web application. I think that's clear. Okay, so the next thing is the -t parameter, where we have to define whether we want to test for cross-site scripting vulnerability or for SQL injection. So we use -t XSS. Then we have the option to set up a delay, where we can set a delay between each request, because the web application firewall may be configured in such a way that if you send too many requests in a very short time of in a very short matter of time, that your IP address will be blocked. But we don't need it for our demo. The next parameter is the output file. So we want a nice HTML file where the results are displayed. We can set up a proxy if we want, like burp or something. We can set up a prefix, so there is a string added at the beginning of every fuzzing string, or we can add a postfix where a string is added at the end of every fuzzing string. Okay, so I think we are good to go. We start the application. And what you can see is that we have sent 185 58, sorry, fuzzing strings to the application, and that the output was saved to results.html. So if we now, how did we call it? Results.html. So we can then open the HTML file. Let's use Firefox, okay. So this is the result that WAF Ninja produces. At the top you have some information like what was the target and was there a delay or not, and so on and so forth. And on the left side, in the fuzz column, you see which string was actually sent to the application. The HTTP status is often an indicator whether the request was blocked or not. For instance, the web application firewall sends the HTTP status 999 back if a request was blocked. Then we have the content length, which may be also useful to analyze whether the request was blocked or not, because sometimes the WAF does not change the HTTP status and just says 200. Expected is also stored in the database of WAF Ninja, because sometimes you send a payload which is URL encoded, and if it gets reflected by the web server at the end, it does not come URL encoded back. So what the WAF tries is to get the result, look in the source code for this value, for instance now the smaller tag, and if it finds it, then it also displays it here in the output column. And working is self-explanatory. You have a no for not working and a yes for working. So what we now try to find is the first thing that we tried is the script tag. And as you can see, as also the tool tells us, it is blocked by the WAF, so we cannot use it. So what we now try is to find another tag. And if we scroll a little bit down, and search for tags, I'll make it a little bit bigger. So I think that's better now. Okay, and now we can look for different tags which are not blocked by the WAF. For instance, we have the image source tag. So what we can do is to verify whether it is a false positive or not. We can copy it and paste it into our application. We send it, and as you can see, it was not blocked by the WAF, and the web application processes it. So what we now do, or what we now need, is a JavaScript function where we can insert JavaScript. Who has an idea which function we can use? On error, very good. Okay, so we try on error equals, okay, without adding anything more. So we try it, and we get blocked. Bad for us. So what we can do next? Who knows another function? On click. We get blocked. Okay, and this is the game that we are going to play. So what we did was we used WAF Ninja and now have a nice list of every JavaScript function that works and which does not work. And there are over 150 JavaScript functions. And actually, when I assessed this open source web application firewall, there was one function which was not blocked and which was also exploitable. Because sometimes you have like JavaScript functions which only work if you have like media on your application, sounds or something like that. So it's a little bit tricky, but there is a function called onWheel, which is not blocked by the WAF, as you can see here, and we can just use it. Yeah. So we try to insert it and see whether we are blocked or not. Okay, and as you can see, we were not blocked. Now the last thing that we need is a JavaScript function, like alert or something, and this is also something that we can look up. So we can see, is alert blocked by the WAF? And the answer is no, it is not blocked, so it's working. So we can also just copy it and on source x on wheel equals alert 1. Okay, I think we are good to go. We send the payload, and then what we have to do is to use the mouse wheel, and as you can see, the payload is then processed by the browser. So we have found a bypass for this. Thank you. So we have found a payload that is not blocked by the WAF, but is requested or processed by the web application. And actually, when I reported this vulnerability, the vendor, he also gave me a small bug bounty. So I was quite happy. And if you also want to try it out, you can just search for WebNight in the internet. And if you find a vulnerability, you also get a little bit of money. Oops. Okay, that's it from my side. I'm happy to hear your questions if you have any. Please. Okay.
You said that you've used Python for the tool. You wrote all the code yourself, or you used the beautiful soup or LMX or some other libraries?
Yeah, did everyone understand the question? He asked whether I use Python as a programming language for my tool. Did I use any libraries or not? Yes, I did use libraries. There is a good library called URL lib2, which is used to send requests and to receive responses, because I didn't want to program something on the socket level. So yeah, I used this library, and it was very good and easy to use, so I can just recommend it. And generally speaking, as I said, you can find WAF Ninja on GitHub. You can download it, try it yourself, and I'm very happy if you could provide some feedback to me. Please.
Have you tested your WAF Ninja also on F5?
No, unfortunately not. I didn't have the chance to. So this paper I wrote, and also the tool, I developed during my bachelor thesis, and I didn't have the resources to buy a F5 for my home lab. So yeah, I only used open source web application firewalls. But there was a paper, I think some months ago, around 6 months ago or something, by a guy called Mazin Ahmed, who found several vulnerabilities in the Imperva firewall, in several commercial firewalls. So yeah, you may also search for this. Okay, I think, yes, please. One moment.
The theory about double URL encoding, did you see it working? That you would evade something? Because double decoding, or I don't know how many times infinite decoding, sounds like incorrect behavior to me.
Yes, correctly. This is incorrect behavior, and if you find such a thing, then the WAF is probably not a good WAF, and you can just dismiss it. I took this technique from a Chinese it was called Web Application Firewall Bypassing Cookbook. So what he was doing was using Chinese web application firewalls and try to find vulnerabilities in them. But you are correct. I wouldn't suppose that the known web application firewalls really only decode URL encoded strings once. So I also think that it's very unlikely that it will work, but it's still a technique, and yeah, there's a small little chance. Yeah. All right, great. Thank you guys for your questions. Thank you for your attention.